Hello, Bacho. How are you? I hope you all are good. Okay, now we are continuing our whatever homeopathy topic, that is metals and non-metals. Okay, so we covered reactions with air, reactions with water. Now it's time to cover our next point, that is say reaction of metal with dilute acid. Okay, reaction of metals with dilute acids. So see here reactions of metals with dilute acids. In that generally what will happen, say metal plus, okay, your metal plus dilute mineral acid, metal plus dilute mineral acid. So what they are giving us? They are giving us metal salt plus what? Yes, hydrogen gas. Okay, so it is very much important here. Metal salt plus what? Hydrogen gas. So this thing you keep in mind here. Whatever our this reaction, metal plus dilute mineral acid, that gives what? Metal salt plus hydrogen gas. Okay, and as you know, hydrogen gas is what they are. How we can show? We can show with the up arrow like this. Okay, now we will see examples on that. So as you know, whatever in our reactivity series, okay, so in that more reactive, okay, so whatever are more reactive metals readily lose hydrogen as compared to less reactive metals. Okay, and if you are considering our activity series, okay, so whatever that metal place above hydrogen in the activity series, they can displace hydrogen gas easily or readily as compared to below that hydrogen. Okay, so it is very much important here in that. Okay, so see here our whatever these examples. Suppose if you are taking concentrated acid and some weak acids. Okay, so concentrated acid and weak acid, or we can say strong acid and weak acid. So what is the difference between these? So first we will concentrate on that. Our strong acid means what? It completely ionizing water. What is our strong acid? It completely ionizing water, and whatever our weak acid is what? Is unionized form in water. Unionized form. Okay, so very much important here. So we will see here, as you know, your HCl, then H2SO, these are what? Strong acids, but your what? Phosphoric acid H3PO4 is what? Your weak acid. So now we will see some examples here. Okay, so see here Al, okay, so Al plus HCl. So what they are giving us? Yes, it gives what? Here in metal. Okay, and as you know, metal is what? Always electropositive, and here what? Non-metal, negative. So wherever necessary, you can what? You can break easily here. Understood? So as you know, your metal is already electropositive. So what they are giving us? Yes, AlCl3, stable binary compound plus what? Yes, hydrogen gas. Okay, so for balancing the reaction, here take 3. Okay, so our reaction is balanced. See, 3Cl, here also 3Cl, but see here like that we have to do for balancing. So see, yes, our reaction is balanced or not. 2Al, 2Al, 6Cl, 6Cl, and hydrogen 6, hydrogen 6. So as you know, our gas is, it will evolve. Understood? So these are what? Means here, whatever your hydrogen gas is evolved rapidly. Hydrogen gas is evolved here what? Rapidly. Understood? Hydrogen gas evolved here rapidly. But why beta like this? Because these are what here? Strong acid. And this strong acid is what? It will readily evolve hydrogen. Okay. Understood? So now we will see here next our reaction. So that next we will see Al Al plus phosphoric acid. So phosphoric acid is what here? H3PO4. Okay. Phosphoric acid is what here? H3PO4. And beta this what? Here this weak acid. This what here? Weak acid. Okay. So whatever rate of displacement. Okay. So rate of displacement of hydrogen gas from your acid, it depends on electropositive character also. So you for this thing also you keep in mind. Okay, whatever rate of displacement of hydrogen from acid depends on what? Electropositive characters of that metal. Okay, so see here Al plus H3PO4. So obviously what you will get here, wherever necessary, I told already, you have to do breaking. So as like this, H plus PO4 3 minus. Here as you know metal is out already electropositive. So here what you will get? Yes, you will get here AlPO4. Why like this formula? Because as you know Al is plus 3, aluminum is plus 3 and PO4 is what? Minus 3. So beta here plus 3 and is minus 3. They will cancel out each other. And you are getting what? Simply LPO4 plus H2. Okay, so for balancing the reaction, okay, so for balancing the reaction, you have to write some whole number, okay, or we can say some stoichiometric coefficient. Stoichiometric coefficient is also called as what? Whatever number for balancing, okay. So see here 3H, so here also 3H. Now we will see balancing the reaction. Okay. So for balancing, we have to do one thing. Here 2, yes. Here also 2. Yes, our reaction is balanced or not. Okay, see, we will cross check beta here. 2Al, here also 2Al. 2, 3 the 6 hydrogen. Here also 6 hydrogen. 2PO4, here also 2PO4. Understood? So our reaction is balanced. But here one thing is that, okay, that one thing is what? Your hydrogen gas is evolved less readily. Okay, understood? Means not rapidly, it will evolve, we can say slowly. Because your acid is what? Beta, your weak acid. Understood? So we will see here some examples. Okay, some examples we will discuss. With sodium metal, then your magnesium metal, zinc metal, how your hydrogen gas is evolved. Okay, see first example, as you know, when Na plus HCl, so beta what, okay, what you will get? Obviously what you will get NaCl plus H2 gas. Okay, so for balancing here, you have to take how much? 2, so here also 2. Yes, see here reaction is balanced or not. 2Na, 2Na, 2 hydrogen, yes, 2 hydrogen, 2Cl, 2Cl. Our reaction is balanced. Okay, your sodium plus Cl, whatever your hydrogen gas is evolved vigorously. Your hydrogen gas is evolved vigorously. Okay, suppose we are thinking about magnesium. Okay. Then Mg plus HCl, what they are giving us? MgCl2, yes, MgCl2, stable binary compound with, you have to balance with the cross or valency also. Whatever valency means Mg2 plus Cl minus, that also we have to think about. Okay, now here H2 gas will evolve, but here what? Less vigorously, understood? Okay, and as you know our reactivity series also, KB Nath Ka Mali, Alu Zara. Okay, so you are remembering all that reactivity series. Okay, okay, very good. Now see, for balancing, yes, here also you have to take 2, here also 2. Okay, so beta we will say 1 mg, 2 Cl, yes, here also 2 Cl, 2 hydrogen, means no need to here take. No need of 2 here. Okay, so our reaction is balanced. Suppose if you are thinking about reaction of zinc with HCl. Okay, so see here reaction of zinc with HCl. Third we will say zinc plus HCl. Yes, what you will get? ZnCl2 plus H2. Very less vigorously, or we can say what less violently it will your hydrogen gases evolve. Okay, so see here 1Zn 1Zn 2Cl. Yes, here also what 2. Okay, then two hydrogens are there. So beta here what our reaction is balanced. Okay, suppose if you are thinking about next one. Okay, so that next one also we will say here fourth one. So that fourth one reaction. Okay, so see very iron plus HCl. Okay, so that iron plus HCl that gives what beta? Yes, FeCl2 plus H2 gas. Okay, hydrogen gas, or we can show to make your reaction more informative. Okay, we can write whatever hydrogen gas is their physical state, or we can say what state symbols. Okay, so for balancing take here 2. Okay, 1 Fe 1 Fe 2 Cl 2 Cl 2 hydrogen. Yes. Okay, now these are what some reactions. Okay, we saw. Now here whatever our fifth reaction is very much important. I hope you understood all these reactions. Okay, now whatever our next reaction, so reaction of copper with HCl. So say reaction, fifth our reaction of copper with HCl. So here beta what will happen on copper if you put HCl here no reaction will occur. What beta here no reaction will occur. Yes, why it is because your copper is less reactive. Copper is less reactive. Okay, then hydrogen. Okay, कौन है आगे आओ. Okay, like that we saw statement in our activity series. Understood? So these are reason. So it can't displace hydrogen from this acid because your copper is what beta less reactive. कौन है आगे आओ. Pantaji. Are you remembering this activity series? So no reaction will occur. So after that here whatever your hydrogen gas, okay, one of the most important here, hydrogen gas is not evolved in a when a metal reacts with, okay, hydrogen gas is not evolved when a metal reacts with whatever your nitric acid. Okay, when your metal reacts with nitric acid, your hydrogen gas is not evolved. Okay, your hydrogen gas is not evolved when metal, say, when metal reacts with nitric acid, hydrogen gas is not evolved. So why it is so? Because here your hydrogen, what will happen beta? This nitric acid. So see, this nitric acid is act as a what? Strong oxidizing agent. Why? When metal reacts with nitric acid, what will not what evolve any hydrogen gas? Because nitric acid is what? Strong oxidizing agent. Okay, so strong oxidizing agent means what? They are super oxidizing agent means like that. See, whatever hydrogen evolved from in this reaction, it will see this oxygen from your nitric acid. It will your hydrogen gas is evolved, but that hydrogen gas it combines with from this oxygen means nitric acid. They are evolving what? This nascent hydrogen. What? Beta nascent oxygen. And this nascent oxygen is what? Their purpose is what? To oxidize. Then what will happen here? H2. Understood? So when your metal reacts with nitric acid, does not evolve H2 gas because what will happen? Whatever hydrogen gas is produced, it will oxidize into your water. it will oxidize into your water. So this is very much important reason here. Okay, so you keep in mind this region. Okay, it will oxidize into this H2O and it will reduce also, and after reducing it gives, see here, after reducing, after what beta here, after reducing, it gives oxides of nitrogen, oxides of nitrogen. Okay, so that oxides of nitrogen is what? Suppose your NO2, okay, simply NO, okay, then N2O3, okay, so like that oxides of nitrogen were formed. So that depends on what? Whichever metal is there. So beta, this keep in mind, this very much important thing. Okay, now we will move towards, okay. But beta, these okay, nitric acid when metal, but your magnesium and manganese, it will react with what? It will react with your nitric acid, your magnesium and manganese. It will react with your nitric acid with evolution of what? H2 gas. So we will see here one example. Okay, beta. So see, Mg plus HNO3. So here what? Yes, here you will get Mg. Yes, here also we can break plus or minus. So this always, as you know, metal is the electropositive. They are taking this minus ion. Okay, so what you will get here? Yes, magnesium nitrate plus H2 gas. So for balancing, take you to gas. 1 Mg, 1 Mg, 2 nitrogen. Yes, here also 2 nitrogen, 2 hydrogens also there. 6 hydrogen, yes, here also 6 oxygen, 6 oxygen. Understood? So very much here, all these concepts are important. Okay, now we will discuss here one of the important. So whatever our reaction with dilute mineral acids are over. Okay, now we will move towards next part. Okay, I hope you understood all this content from our this topic. Now reaction of metals with some salt solution. Okay, now we will discuss that. See the heading: reactions of metals with salt solution, with salt solutions of less salt solution of less reactive metals, less reactive metals. So here also means what here beta, your less reactive metal displace. Okay, what is here? Reaction of metals with salt solution. So say, sorry, here more reactant, sorry, more reactive metal displace less reactive metal from its salt solution. Okay, so here we can write, so what we can write here, see, more reactive metal displace less reactive metal from its, yes, from its salt solution. Okay, and this type of reaction we also called as what? And this type of reaction is also called as yes, displacement reaction. Understood? So this displacement reaction we have to say in our next topic also, that for homeoba, that is chemical reactions and equations. Okay, now we will see here, suppose now we will see here one representation. Okay, so that general reaction we have to see. Okay, That general reaction, how it is? See, M1. M1 is what beta here? More reactive, yes, more reactive metal. Plus salt solution plus salt solution of M2. Salt solution of M2. Okay, so beta it is salt solution of M2 means what here? Less reactive metal. Less reactive metal. So what it will get? It will get here M2. Okay, so M2 plus what you will get? Yes, salt solution of M1. Salt solution of M1. Okay, so understood this, more reactive metal displace less reactive metal from its what? Salt solution. So you will get like this M2 plus salt solution of M1. Okay, where M1 and M2, that is important. Say where M1 and M2, these are what? Two different metals. M1 and M2, these are what? Two different, yes, two different metals. Okay, so now we will say some examples here, some simple examples. Okay, but on the base of reactivity series, whatever this reaction we have to, okay, do whatever we have to consider here reaction on the base of what? Our reactivity series. So well known, as you know. Okay, so reaction of your iron with copper sulfate. First example, reaction of iron solid with copper sulfate aqueous. So this beta we can perform this activity in chemistry lab also. Suppose you take iron nail and you in another beaker you have to prepare solution of copper sulfate aqueous. Okay, so if you put that whatever your iron nail, so after some time it will, what will happen? Yes, that color of that copper sulfate is fades. Solution becomes what? Turn light green color. Okay, so see here that reaction, iron solid plus copper sulfate aqueous, as you know it is what? Blue in color. So what here you will get? Yes, here you will get FeSO4 plus what? Beta copper. Okay, understood. So like that here simple reaction, but here beta color is what? This solution color become fades. Okay, and here you will get what? Green color. Understood. So we will see another example also. Second example, reactions of magnesium. Okay, reaction of magnesium with copper sulfate solution. Okay, so see here your magnesium solid plus your CaSO4 aqueous. So as you know the color of this, yes, color is what? Blue. So it will, you will get what? Yes, MgSO4, but that MgSO4 color is what? Colorless. Aqueous plus here what? Copper. So here beta colorless. Understood. So these are simple reaction. Whenever more reactive metal displaces less reactive metal from its salt solution. Okay, so we will see some more examples on this. Understood this all? Now we will see reaction of silver. Third example, reaction of silver with copper sulfate. See in that reaction of silver with copper sulfate, Okay, so as you know, our Ag solid plus beta copper sulfate aqueous. So here it can displace more reactive metal. So beta, basically whatever this is what your more reactive, so it can't displace. Okay, according to our reactivity series. So here what will happen? No reaction. Keep in mind this. Okay, so first say our activity series also. In that also we can easily visualize that whichever upper side is what more reactive. So here it can't displace your copper. Okay, because as you know your silver is what less reactive. Silver is what your less reactive than copper. Okay, we will see some more examples. Okay, so see more examples also. We can write directly Zn plus CuSO4, it can displace. Yes, here it can displace. Copper is displaced. What will form? Here blue. Then here what? ZnSO4, which color? Yes, colorless. Which color? Colorless. Plus what here? Cu. So beta here your copper is displaced easily. So we will see here some another example also. Okay, suppose if you took here fifth one, Zn plus iron sulfate. Yes. Okay, your iron can displace. Yes, iron is displaced. So what you will get? ZnSO4. Yes, ZnSO4. It is what your green color. Here what? Colorless. Plus what? Iron solid. Here you will get. Okay. So these are simple reaction. Okay. So we will see in some example your silver also displays or not. Okay. Next our reaction. Okay. Suppose if you copper plus what? Ag2SO4. So here it can displace. Yes. Here whatever here this silver it can displace because copper is what here more reactive. So what you will get? Yes, here CuSO4. Okay, then what you will get? Ag to Ag here you will get. But here balance the reaction. It is balanced. This is what beta here? Silver sulfate. As you know, according to our crossover valency, this two of what? Sulfate ion. And this what you will get here? Blue in color. Here you will get. So our reaction also balance. Suppose if you took here iron also. Okay. So suppose iron if you took here. Iron plus Ag2SO4. Iron also more reactive. So it can displace your Ag. Ag is your less reactive. So FeSO4 plus what you will get 2Ag. Okay. So for balancing, yes, our reaction is also balanced. Okay. Now we will see some extra examples on this and some exceptional cases. In that no reaction will occur. So that we will now discuss here. So say, suppose if you took copper, iron and what here? Ag. Copper, iron and Ag. When it reacts with, okay, when it reacts with ZnSO4. So beta here reaction will occur or not? Your whatever more reactive metal. So as you know our reactivity series. So beta here simply, okay, your zinc is what? More reactive. Okay, so it can't displace. Okay, so beta here simply what will happen? No reaction. And one more, suppose if you done copper, silver, when it reacts with FeSO4 solution. aqueous. Aqueous. Okay, here also what beta? Aqueous. So what you will get here beta, you will get here no reaction will occur. What will happen? No reaction will occur. Okay, so see, because beta here iron is what? Iron, yes, iron is what here? More reactive. Okay, so you have to keep in mind all these reactions. Okay, so we discussed so many things here. I hope you all understood all these things. So we will continue our next lecture within a second. Thank you.